Hi everyone, welcome to this video on molar volumes of gases. So I got a question for you. If I've got 1 mole of a gas, so in other words, 6.02 times 10 to the 23rd entities, how big would the box have to be? It have to be small, big, size of a room? What would it be? Well, we're going to find out in this particular lesson. So to do this, we're actually going to figure out how much volume 1 mole of helium gas has. So what we know is that helium gas has a density of 0.1786 grams per liter. Very light, and that's why it can float. Helium balloons can float. Now this density is only true at standard temperature and pressure. So you have to be very careful with this. So to figure out what's going on here, I need to know how many grams there are in 1 mole of helium. So we know that molar mass, we've got 4 grams in 1 mole for helium. I'm going to use that as my mass. The density, as I said earlier, was 0.1786 grams per liter. And I want to figure out what's the volume of this 1 mole of helium. So my density equation from grade 9 is my mass over volume. That's the definition of density, how much mass there is in a certain volume. And I'm just going to rearrange it to solve for volume. So I'm going to bring the V up here, the D down here, and substitute my values in here. So what I have is I've got 4 grams per mole. My density is going to be 0.1786 grams per liter, and you end up with this number, 22.4 liters. So per mole. So 1 mole of helium has a volume of 22.4 liters at STP. Well, that's not that bad. It's about 22 milk cartons, 11 big pop bottles, I suppose. All right, let's do the same thing with neon now. So neon gas is a little different. It has a little bit of a larger density. Its density is 0.901 grams per liter at STP. So we're going to look at 1 mole of neon. So 1 mole of neon has a molar mass of 20.18 grams per mole. And the density, as it says, 0.901 grams per liter. We're going to use the same equation as the previous question to figure out the volume. And you end up with 22.4 liters per mole. So again, the same value. How is this possible? Well, it's an interesting phenomenon. And Avogadro, scientists have come up with this notion that any gas, for any gas, 1 mole of that gas has a volume of 22.4 liters. So it doesn't matter if it's helium, hydrogen, oxygen, argon, chlorine, as long as they're at standard temperature and pressure. The masses will be different, but the volume will always be 22.4 liters. Neat thing. All right, so this is the note that you have already in your workbook. You can see here that we've already done the first few examples here. I believe this is workbook 124. All we have to do is complete the middle of the note here. So the volume of 1 mole of any gas is equal to 22.4 liters as long as it's at STP. And then I can use this little conversion factor in any kind of conversion that I have. So let's look at a couple of examples. So what I have here is I want to know how many moles there are in 112 liters of oxygen. Well, it's like any gas. I know that 1 mole is equal to 22.4 liters. So I just use the appropriate conversion factor. Here I want to get rid of liters. So the liters are at the bottom. So 112 liters divided by 22.4 gives me 5.00 moles of oxygen. Let's look at another one. What's the volume of 0.2 moles of hydrogen? Well, I know that I've got 22.4 liters in 1 mole. Use the appropriate conversion factor, so the units are going to cancel. So in this case, we're going to have the moles cancel, end up with 4.48 liters. So very, very, very easy. Here's a little bit more of a challenging one, so to speak. What I have here is I want to figure out how much mass there is in 896 liters of oxygen gas. So it's trickier only because we have to, from the volume, we have to figure out the mass. The only way we can do that is to do the number of moles. So I know for oxygen, my molar mass is 32 grams per mole. And I know my volume is 896 liters. So those are some of my givens. So I'm going to figure out the number of moles first. I'm going to do step 1 here. So it'll be over here. So I know that 896 liters is equal to 40 moles according to my conversion factor over here. So I got 40 moles of this oxygen, and I'm going to use my molar mass to figure out how much mass I have, how many grams we have. So this will be the second part of the question. So again, 40 moles times 32 grams in every mole gives me 1,280 grams. So basically, 896 liters of oxygen has a mass of 1280 grams. Now, before we go on, I just want to remind you guys of the mole cross we talked about earlier. So what we have is this. The mole is in the center of all of these different factors. So if I want to figure out the number of entities, I have to, from the moles, I can use the Avogadro's number to figure out the entities, or from the entities go to the number of moles. If I have mass to moles, I can use my molar mass, which we did here. We can also use this relationship here with volume. I know that 1 mole is equal to 22.4 liters. And the one we did last unit was we used the concentration, the molar concentration equation with the number of moles per liter to figure out concentration or volume. So by doing any of these conversions, we can do pretty well any question at this point in time. So again, you have a few textbook questions to try out. Make sure you check the answers in the back of the textbook. Enjoy, but make sure that you are actually doing them, okay? And do a little bit of problem solving. Take care.